Hello and welcome. This video will cover the cantilever beam experiment. In this experiment, we have a cantilever beam fitted with strain gauges, which connects to a strain gauge bridge, which fed to a strain gauge amplifier. We have a dial gauge here at the far end of the cantilever, and we always can set the length of cantilever beam by opening this G-clamp, move it forward or backward, depends on the length required as per your sheet, and then we can load it at the end here. So let's perform a quick experiment in here. The length of the cantilever beam I have right now is set to 50 centimeters, and always we measure the cantilever beam length from the edge of the table or plinth which is supporting the beam. So it's not the full length to the end of the beam here. The cantilever beam length is the floating area length of the beam. We will need a vernier caliper to measure the dimensions of the beam. We'll need a weight hanger to load the beam at the end there, and of course some else. Now, before starting with the experiment and loading the beam, we'll need to make sure the amplifier here reads 0, and we can change that using the offset knob. So here we got 0. We'll need to make sure the dial gauge is reading 0, in which we can turn this outer face of it till we get the pointer points to 0. Now always we need to make sure the dial gauge is touching the cantilever beam and has enough distance to move. You can see here, as I load the beam, we get movement. Now a full turn on this dial gauge is going to give you 1 millimeter. And 1 millimeter is divided into 100 divisions. So full turn of the dial gauge is 1 millimeter. We'll start with the first load, which is the hanger only. The hanger itself is 100 grams. Now you will need to follow your sheet on the steps required. In here I'm going to load it with 100 grams at each step. Then we'll get the reading from the dial gauge and the strain gauge amplifier. So now I have a strain gauge amplifier reading of -1, minus because it's moving to that direction. Okay? The dial gauge is also in minus. In this case, we will need to read the red range. So on the dial gauge, always we read the red scale, and in the strain gauge, always we include the negative sign. Now -1 in here and is about 22 divisions. Now I'm adding another 100. In here we got almost double what I got previously. I have 44 divisions in here now, and here -2. It should be really sort of linear increment. However, on each step you will need to get the exact reading. So basically, during the experiment, we'll keep adding weights in certain steps. I'm using 100 grams or 1 Newton steps at each time. At each step, you will need to note down the reading of the dial gauge and the strain gauge amplifier. Now, based on your sheet, you might be required to do different trial with different length of the cantilever beam. If that is the case, then after finishing with the first set of readings, you will need to remove the hangers and the loads. You will need to move the dial gauge. Then you can adjust the length of the beam. Let's say I would like to do 40 centimeters. So I'll push the cantilever inside for 10 centimeters. Then I can tighten up the G-clamp. After we tie this up, we'll need to confirm the required length. It should be again the length from the edge of the table to the end of the beam. Now we get the dial gauge back. we try to keep it at the edge as much as possible so it can give us right readings. We'll need to make sure the strain gauge amplifier is reading 0.